morning, geometry students. Oh my God, who's the bald guy? I thought Miss Newman was helping us out. My name's Mr. Krause. You won't see me do too many geometry videos, but she forgot to do some promos for the beginning of these, so I thought I'd add them in and say hi. Anyway, this is the Geometry June 2017. This is going to be parts 2 through 4. And again, all of this information can be found at www.nkinfinity.com. If you haven't heard me say it or Miss Newman say it before, make sure you hit subscribe, because she and I do a ton with Algebra 2, more than you'll ever even know or could ever even use. So if you're going to take Algebra 2 next year, it'd be a really good idea to get subscribed to our YouTube channel. Get on, check our videos out. We're going to be posting lots and lots of review. We're going to be doing a few things differently next year, so hopefully you get on board with us. Anyway, Miss Newman will be right up. She's going to be covering parts 2 through 4. I hope you did okay. And again, we are sorry that it took us so long to get these up, but it wasn't our fault. New York State restricted us from getting these up until June 30th. So I'm going to be posting them up 12:01 probably on June 30th. All right, catch y'all on the flip side. Goodbye.
All right, so as you know, I don't have a compass and straight edge on this computer, so this is kind of a rough estimate of what you should do. You're given this trapezoid, you know the two sides are parallel. It says using a compass and straight edge, construct an altitude. You have to know the definition of altitude is that it forms a perpendicular. It's perpendicular through J to ML. Okay? That's what you're trying to do. So you're trying to get like this straight line there. That was a beautiful straight line, wasn't it? Okay. So what you want to do is you want to put the center of your compass at J, and you want to measure a radius past the distance to ML and make an arc. Okay? Obviously, mine's just very beautiful. Then you want to put your center at this point, and you want to measure past halfway. So you can see that halfway would be like there. Past halfway, and create an arc above and below. Now using that same measurement, put the center here and create an arc above and below. Whoops. Now take your straight edge, and this is where I always try to use these lines, right? Take your straight edge and connect those through there. Should look something like that, and put your right angle on it. There's your altitude. Beautiful. Actually, that was pretty good. I'm not going to lie. Okay, so 26. Determine and state in terms of pi the area of a sector that intercepts a 40-degree arc of a circle with a radius of 4.5. You've got your compass out, so you may as well draw a circle. I think I can get a circle here, yeah? You had your compass ready anyways, so there's my circle. To the best of my drawing abilities, yours will be perfect. The area of the sector intercepts a 40-degree angle. So let's see, 90 would be like that, so 40, I'm going to guess, is like this. All right, so this, an arc of 40, which means a central angle of 40 degrees as well. So in the circle is 40, on the circle would be half. Okay, so, and it has a radius of 4.5. It wants it in terms of pi, which leads me, I guess it doesn't matter. And they're giving me the angle in degrees. So the area of a sector is a fraction of a circle. It's the fraction of the angle out of the 360, right, of pi r squared, a fraction of the circle. So the area is equal to 40 over 360 pi 4.5 squared. It wants it in terms of pi, so that means you just enter all of those numbers into the calculator without the pi. So let me clear this out. Doc B. Control divide. 40 over 360. Oh, that is not a 0. 360. And then 4.5 squared. .25 pi. Don't try to be fancy, just write it down. A equals 2.25 pi. If you wrote 9 pi over 4, that is also correct. Moving on. In the diagram below, the diagram below shows two figures. Figure A is a right triangular prism. Figure B is an oblique triangular prism. The base of figure A has a height of 5 and a length of 8, and the height of prism A is 14. The base of figure B has a height of 8 and a length of 5, and the height of the prism is 14. Use Cavalieri's principle to explain why the volumes of the two triangular prisms are equal. So I know this is probably like very informal and very like weird to say, but when I think about this, I think about the Tower of Pisa for some reason, because it's like you took the shape and you like kind of smushed it around. The volume of the shape hasn't changed. It's just kind of tipped over or rearranged. So each cross section has the same area as it used to. So if you look at this flat surface, this flat triangle here, in figure A, the area of that triangle, the area of the base of the figure, is 8 times 5, which is what, 40? So that triangle has an area of 20. Same thing here. That triangle, 8 times 5, is still 40. Half of that is still 20. And then the height of the whole figure is still 14. So every cross-section adds up to be a volume. So Cavalieri's principle basically says that. So since the bases and heights of the figures, are equal, I'm going to write the word equal, every parallel section, I'm going to say cross section, is congruent, making the volumes the same. Sorry. All right. When volleyballs are purchased, they are not fully inflated. A partially inflated volleyball can be modeled by a sphere whose volume is approximately 180 inches cubed. After being fully inflated, the volume is approximately 294 inches cubed. We haven't changed units, thank goodness. To the nearest tenth of an inch, tenth of an inch, tenth of an inch, tenth of an inch. How much does the radius increase when the volleyball is fully inflated? Okay, so we're starting with partially inflated. And so the volume of a partially inflated is 180, and the volume of the sphere is 4/3 pi r cubed. So what we got, 180 is equal to 4/3 pi r cubed. Yeah, and we're looking for the radius. And then the fully inflated, same formula, 294 is equal to 4/3 pi r cubed. We're still looking for r, and then we're comparing them. So I want to get the 4/3 pi on the other side. And normally I wouldn't say to do this, but I'm going to say to do this. Divide by 4/3 pi. It's not the right way to say it. You would normally want to multiply by the reciprocal and all of that jazz. I don't have time for that. You're going to get a crazy number here, and we'll do it in a second. And to undo a cubed, we cube root it. So we're going to do all of this like right in our calculator. So we're going to end up cube rooting that number to get our radius, because I don't want to round. So what's 180? Okay, doc B. Control divide. 180 divided by 4/3 pi. That's the wacky number. Now we have to cube root it, right? So to do that, you do control and then see the caret key. You'll see the N in the blue or yellow or whatever. We want the cube root of our answer. Control answer. 3.50263. And I'm going to write out the whole wacky number. 3.5026329,748. Ew. We're going to do the same thing over here. We're going to divide by 4/3 pi. The number we get is going to be icky. And so it's going to be in here, and we're going to cube root it to get r by itself. So r is going to be some other crazy number. So control divide. What's the top number? 294 over 4/3 pi. Crazy, crazy number, right? And then we want to cube root, so control caret key. Cube root of our answer. Control answer. 4 point blah blah. Okay, so I'm going to write that number down. Hello, marker. 4.1249,584,0602. Okay, and it asks you how much does the radius increase? So I'm going to subtract those two numbers. So fun fact, you can take that number, highlight it, minus, go to the other number, the 3.5, highlight it, press enter, 0.622, and it says to the nearest tenth of an inch. So I'm going to call this R1 and R2. R2 minus R1 is 0.6 inches. Yay. Ew, right? All right, so 29. In right triangle ABC shown below, altitude CD is drawn. So you have to know, again, the word altitude means right angle. By the way, I'm going to change my color. I don't like this blue. It's drawn to hypotenuse, AB, explain why they're similar. Well, it tells me that ABC is a right triangle. And clearly that would mean that C is the right angle. Yeah? Okay. So I got some things to write down. Triangle ABC is a right triangle with angle C as the right angle. I don't know why I said that the way I did. That's a weird way to say it, but whatever. Okay. ACD. So triangle ACD is also a right triangle, right? So I said it weird here, okay. Triangle ADC has a right angle at D because altitudes form right angles. Yeah? And then clearly ABC and ADC share angle A, so they have angle-angle similarity. Let's see. Triangle ABC and triangle ADC share angle A. Therefore, by angle-angle similarity, triangle ABC is similar to triangle ADC. Done. Nothing crazy. You could have done it in a column proof if you wanted, that's fine, but you have to say a lot of things here. Okay, 30. Triangle ABC and triangle DEF are drawn below. Write a sequence of transformations that map the triangle ABC onto triangle DEF. So the best way to do this is to draw your little vector. So I want to use this, but I want those drawing tools, and I don't know where they went. Draw. I'm going to try to use this, and I'm going to, oh, darn. Okay. So, oh, come on. I had it just a second ago, didn't I? And I had to goof it up. Okay, so there's my vector from A to D. So there's vector AD. Cool, right? That was cool. I actually feel pretty proud of myself. Okay, so we're going to translate because it says AB is congruent to DE. AC is congruent to DF. Okay. And angle A is congruent to angle D. So these guys. So I'm trying to bring A to D and then turn it. So if you can imagine sliding it and then turning it so it matches up perfectly. So first thing I'm going to do, and I'm actually going to end up writing it up here just so you can see what I'm writing. Translate A, or triangle ABC, along vector AD. Okay. Then, once it's there, so to the best of my drawing abilities, and I don't know, so I'm going to try to redraw it. This is not going to be great, so don't judge my drawing skills. Okay, was proud of my line, and now I'm not so proud of my picture. A prime, B prime, C prime. Okay, so now I have to figure out how much to turn it. So I want to turn it so that B goes all the way to E and C goes all the way to F, and I want this A prime, B prime side to match with DE. So I need to turn it this many degrees, whatever this many degrees is. So I want to turn it through the angle CDE is really it, right? CDE. That looks like a straight line. It's not. My picture is just terrible. Or CDF. I'm trying to, because it's got to go a little bit further there. Yeah, CDF. So that it all matches up perfectly, because this side, CA, has to match all the way with that side. So I'm going to rotate triangle A prime, B prime, C prime about angle D for angle C prime D F degrees. Now, if you wanted to call this like X degrees or something and you called it that, that would be okay too. Blech, that was icky. You probably had your transformations right and maybe you just weren't specific enough. That's all, I would guess. All right, 31. Actually an easy question if you know a fact. There's a fact you had to know here, so this is a big deal. I better be recording. Okay. Because I just did way too much. Line N is represented by this equation. So this is my equation. Determine and state the equation of line P, the image of line N, after a dilation of scale factor 1/3 centered at the point 4, 2. The use of the set of axes is optional. Okay. I would hope that the very first thing you guys do when you see this is you get it into y equals mx plus b form, because that's how you best understand lines. So I'm going to subtract the 3x over. So 4y is equal to 20, I don't know why I scribbled, is equal to negative 3x plus 20. And then I'm going to divide both sides by 4. 4's cancel, and I have y equals negative 3/4 x plus 5. Okay, so I know how to graph that pretty awesomely because, you know, I passed algebra 100 years ago. 1, 2, 3, 4, 5. Let me just check. 1, 2, 3, 4, 5. Okay, and I know the slope is negative 3/4, so down 3 over 4. Oops. Down 3 over 4. Don't rush this part, okay? This is the stuff you're good at. Don't get it wrong. Okay. Ugh, come on. I'm going to try to draw my line again because I was so proud of my other drawings of lines that we'll see how it goes, right? Let's see if I can. Oh, come on. That was not great. Oh, that was, though. Yes. Nailed it. Okay. So there's my line. Y equals negative 3/4 x plus 5. Great. And it says to you to determine and state the equation of line P. So this is N. Line P, the image of line N after dilation of scale factor 1/3, centered at the point 42. So you got to plot the point 42. So 1, 2, 3, 4, 2. Oh. Oh. Fact. If the center of dilation is on the line, then the image is the same line. That's a fact you have to have in your brain. So it asks you to state the equation of line P, but line P is just going to be the same. So my justification here, it says explain your answer. So I'm going to go up here and I'm going to say P is also 3x plus 4y equals 20 because 4, 2 is on line N. So the equation of P, so if N is dilated through a point on itself, the image is the same line. Or itself, whatever you want to say. So that's actually a really good question. It's just testing one tiny fact. All right, part 3s, here we go. Triangle ABC has vertices -5, 2, -4, 7, -2, 7, and triangle DEF has vertices blah, blah, blah. Graph and label on the axes below. Determine and state the single transformation. Okay, so not a tough question, actually. So I'm going to go ahead and plot my points. This was a generous question, I thought, but maybe you didn't think so. So -5, 2. 1, 2, 3, 4, 5, 2. Oh, this is awful. I hate this. Okay, sorry. I might just have to use a fatter marker. Can I fatten this marker up or what? Draw. It's just so annoying that it's... we'll do that. Okay. Okay, there we go. B is -4, 7. 1, 2, 3, 4, 5, 6, 7. And C is -2, 7. So this is A, B, C. And we know how this is going to turn out in terms of my drawing, so if I try to use those lines, it's going to be a hot mess, so I'm not even going to try. I'm going to use green for the other one. DEF, 3, 2, 2, 3, 2, 2, 7, and 0, 7. Ugh. So line, connect these to the best of... You better use your straight edge because these are embarrassing, just so you know. If you're not using your straight edge, pull it together, okay? So they're asking what single transformation gets us there? Well, it's obviously a reflection, but you have to figure out what's the halfway point. Okay, so what's halfway between C and F? Well, it looks like this guy right here, which is this line. And one of the biggest mistakes I have seen from kids since the beginning of time, also known as since, I was in high school, is not knowing equations of vertical lines. It's x equals -1 there. So up here where it says determine and state the single transformation, it's a reflection through or over the line x equals -1. If you wrote y equals -1, you lost a point. If you wrote y-axis, you got a bigger issue. Okay, use your transformation to explain why triangle ABC is congruent to triangle DEF. I said a reflection is a congruence transformation. One of the other grown-ups at my school, so one of the other grown-ups said, they used different words, but they said the same thing. Something about rigid motion, I want to say. A reflection in a line is a rigid motion which preserves distance and angle measure. So either way, a reflection is a congruence transformation. That's enough. Okay. Oh boy, I just don't want to. Given RS and TV bisect each other at point X, TR and SV are drawn. RS and TV bisect each other. So R to X, X to S, T to V, X to V. Got it. Oh, and then vertical angles. I'm going to call these 1 and 2. So I'm going to get side angle side, right? Vertical. And then these two are bisect, right? So I'm going to get 2 congruent triangles. And then I'm going to try to prove TR is parallel to SV. I'm trying to get that these two are parallel. Let me highlight. This is parallel to this. Well, once I get those triangles congruent, I can say T and V are congruent. Alternate interior angles, therefore parallel lines. Okay, so that's what I'm going to do. I'm going to make a 2-column proof, so I'm going to get my lines here. I don't like to go straight in the middle because statements are usually shorter than reasons. Okay. I'm going to try to change that again because it's a little too fat now. What do you think? Statements and reasons. All right, so step 1 is always the given. So I'm going to write my given. Sorry, I lost my page. I don't even know what number this is right now. I did too much paper shuffling. Hello. There we go. Okay, so RS and TV bisect each other at point X. 1, given. 2, let's see, TX is congruent to XV and Rx is congruent to XS. Definition of bisectors. I mean, if you don't know what a bisector is, we got a bigger issue, right? 3. Angle 1 is congruent to angle 2. Vertical angles are congruent. Okay. 4. The triangles are congruent. Triangle, and I want to make sure I say this right, TRX is congruent to triangle VSX, side angle, side congruence. All right, so number 5. Angle T is congruent to angle V. Corresponding parts of congruent triangles are congruent. 6. TR is parallel to SV if alternate interior angles are congruent. Then lines are parallel. Yay! Look what we can do. Not a bad proof. In terms of proofs, it could have been way worse, right? All right. 34. Weird, right? You looked at it and you thought, huh? It's actually not bad once you wrap your head around it. This is probably a question that I would have looked at, went, huh? Moved on, and then come back to it and like really gathered myself. A gas station has a cylindrical fueling tank that holds gasoline for its pumps as modeled below. The tank holds a maximum of 2,000 gallons of gasoline and has a length of 34.5 feet. You can tell it's a cylinder. You got that. No big deal. They're mentioning gallons here, and they're mentioning feet here. And so there's going to be some kind of conversion, you can tell. A metal pole is used to measure how much gas is in the tank. To the nearest tenth of a foot, so we're going to be working in feet, how long does the pole need to be in order to reach the bottom of the tank and still extend 1 foot outside the tank? So this has to be 1 foot. And then we're trying to figure out what this is, right? This is what we're looking for. I don't even know what I called it. Oh, which is the diameter of the cylinder, yeah. I'm going to call it D for diameter. So we have the volume, kind of. They do give us here that 1 cubic foot is 7.48 gallons. So I'm going to convert, some things here in just a second. So I have 200,000 gallons, and I'm going to convert that to cubic feet so I can use volume and all of that. So 1 cubic foot is 7.48 gallons. How many cubic feet? I guess this is the volume I'm looking for. Volume in feet cubed is 20,000 gallons, right? That's what I'm looking for. So 7.48 times V is equal to 20,000, cross multiplied. Divide by 7.48 to get the volume. So I'm going to use my calculator. Doc B. 20,000 divided by 7.48 is that icky number. So I'm going to write that down. Hold on. Do not round that. 2673.4 0.79679. I don't think that's where that ends. 144. V cubed. Okay, so I have the volume. Now I'm going to find really the radius, which is the diameter, which will help me find the diameter, and then add a foot to it. Okay, so actually equals 2 radiuses. So my answer is going to be 2 radiuses plus 1, right? That's essentially what I'm going to do. So the volume of a cylinder is pi r squared times the height. And really the height is this right here. I know it doesn't look like height, but so that volume number here, 2673.79679,144 is equal to pi r squared times, and what did they say, 34.5 feet. So I want to solve for r, which means I'm going to divide by the 34.5 and the pi all at the same time. I'm allowed to do that. 34.5 pi. That'll cancel the pi. They'll cancel 34.5, and then I'll just have to square root. So r squared is equal to some crazy number, so r is going to be equal to a different number. Okay, so I'm going to take my volume number, I'm going to divide by 34.5 pi. So divided by 34.5, parentheses, Patrice, 34.5 pi. Getting there. Okay, that's what r squared is equal to. So I want to take the square root of that number. Square root of this number is equal to my radius, 4.966. 4.96683479639. Now the diameter is 2 times that, right? So times 2. And my final answer is plus 1, right? So the pole, what is it called? The metal pole has to be 93366, blah, blah, blah. But they say round to the nearest tenth. So the metal pole is 10.9 feet. Wow. Yowza, right? Lots of things going on there. All right, so on to the part 4. Okay, so in terms of part 4s, this wasn't a bad one. In terms of difficulty and all of that. It was lengthy, that's for sure. So quadrilateral PQRS has these vertices. Prove that it's a rhombus. I'm not even going to graph it yet, because if I want to prove something's a rhombus, there's 2 ways I can do it. I'm going to guess that 90% of students would just do distance formula for all 4 sides and say they're equal. Done. That's what I'm going to do, because that's what I think most kids would do. You could also figure out that they have congruent diagonals by doing distance formula for PR and QS and saying if a quadrilateral has congruent diagonals, then it is a rhombus, and that's fine. Okay, the way I like to work this, and I'm just trying to keep everything very simple and basic, is I like to state the fact first. If PQRS is a rhombus, then PQ is congruent to QR, is congruent to RS, is congruent to SP, right? 4 congruent sides, period. It's a property of a rhombus. So I'm going to do PQ is equal to the square root. Now I got to make sure I keep these in order. Okay, so -2 minus 3 squared plus 3 minus 8 squared is equal to QR equals the square root 3 minus 4 squared plus 8 minus 1 squared. RS is equal to the square root of 4 minus -1 plus 1 minus -4. And then S to P. Let's do here. -2 plus 1 squared plus 3 plus 4 squared equals. So I'm going to go to my calculator now and do all of that. I'm going to clear out all this stuff. I'm actually going to move this over so I can see all of this, right? It's kind of hard to, oh my word, I am not good at this mouse. All right, I'm having a hard time. Okay, so square root -2 minus 3 squared plus 3 minus 8 squared. Okay. Whoops. Square root 3 minus 4 squared plus 8 minus 1 squared. Same. Okay. Control square root 4 plus 1, oh, that should be a plus 1 squared plus 1 plus 4, whoops, 1 plus 4 squared, same. And my last one, whoop, sorry computer, didn't mean it. -2 plus 1 squared plus, okay, so I got all the same number. Obviously it's not a perfect square, so I'm actually going to figure out what that number is supposed to be. It's supposed to be 50. Okay, so these are all square root of 50. Square root of 50, square root of 50. So now I feel really smart, right? My calculator's doing all the math. I just plugged it into a formula. So, since PQ is equal to QR is equal to RS is equal to SP, PQRS is a rhombus. Period. I nailed it. Okay. The next part says, and you could have done that with diagonals too. It would have been a little bit less work. State the fact, do the math, give a summary. Prove that it is not a square. So if it's not a square, then that means it doesn't have a right angle, right? That none of them have right angles, right? Sorry. So I have to prove that two of the sides are not perpendicular and they don't have negative reciprocal slopes. So I'm going to find adjacent sides. So PQ and QR. So I'm going to state the thing. So sorry, I'm going to go here. I want to do a proof by contradiction, but I don't think you guys do those. In a square, adjacent sides are perpendicular. So, I'm going to write, they have negative reciprocal slopes. That's the fact that I know in my brain. So I'm going to say it out loud. Does that make sense to you? So now I have to do that with math. I have to show, I'm actually showing that they don't have negative reciprocal slopes. So P to Q, or the slope from P to Q, I should say, change in Y over change in X. I like to write that just so I don't get confused. P to Q. So I'm going to do, let's see, 3 minus 8 over negative 2 minus 3. That would be negative 5 over negative 5, which is a slope of 1. And then the slope from Q, PQR, Q to R is equal to change in Y over change in X. That does not look like Y, I apologize. Q to R, so 8 minus 1 over 3 minus 4. That's 7 over negative 1, which is negative 7. PQ is not perpendicular to QR because they do not have negative reciprocal slopes. Therefore, since adjacent sides are not perpendicular, PQRS is not a square. Yikes. Okay. A lot of things going on there. If you you probably graphed it and did it all on the graph, and that's fine. It's just hard for me to graph and make a pretty graph, as you've seen throughout this video. So thanks for watching. I hope this was helpful to you. We will see you soon.